Hi, this is Pastor Bill in my basement again, and we're continuing the Pastor Bill Makes a Mirror project, or dies trying. Right now I finished what they call hogging out, which means grinding out most of the glass from the center of the mirror, and I've reached my what's called a sagitta, which is the deepest point in the center of the mirror. I wanted to reach .08 inches, and let me show you. Come up, bring that up to the top. Up to the top here, and we'll put this like that, and here we have a little gauge, and we're going to put it, and if you can see, why don't you look straight down from the top. See the gauge? It says .08 on it, so I'm in the ballpark for my sagitta. Now basically from here on out, I have to polish the glass. As you see, the glass is opaque. I'm going to keep polishing it and reducing the amount of pits in the glass with smaller and smaller grit sizes until I get a nice, smooth, and clear surface. And the way I'm going to do that is I'm going to just put the mirror on top of the tool and just nice and easy back and forth motion, and then turn the bottom and turn the top, and then what I'm going to do is reverse it and put the tool on top, and a nice easy motion with the tool on top. That way I keep the sagitta. When the mirror is on top of the tool, the sagitta gets bigger. When the tool's on top of the mirror, the sagitta gets smaller. So I'm going to do a little of both in order to keep it around the area, around the depth that I want to make it, and that's because it just needs to be in the ballpark. It doesn't need to be exactly right, because when I'm finished and I put this in a telescope, I can adjust the focal length at that point. So that's pretty easy to do. Now, what I'm doing is I'm working on different grit sizes. The most recent grit size is 220. Is that 220? I can't even see it. Or is it 120? 120. Okay, that's the most recent one I'm doing, and I'm going to move to 220 grit, which is here somewhere. Here's the that's an old grit. Here's the bag of 220. That's a little bit smaller. And what I need to do is it takes about an hour per grit to get rid of all the pits. Each grit leaves little holes, little pits in the mirror surface, and so I have to remove the larger pits. Now now I'm going to show you what a pit looks like, because what I have to do after about an hour of working on this with 220, I'm going to have to examine it and see if there's any more 120 pits. So how do you do that? Well, let's take a look here. Let me see if we can do this. Nice bright spot here. So I'm going to look at the surface here, and I'm going to look for bright shiny spots, tiny little bright shiny spots. And I know there's one or two left on here to show you. Oh, it's being a pain. I can't find it right now. Let me take my glasses off. There's one. Now, with a magnifying glass, or in this case, there we go, a 25 millimeter eyepiece, you can see it lights up. So why don't you bring the camera down here, Rich, and see, can you focus on that? You see the little bright circle?
I see a low.
Yeah, that's a 120. No, that's a 60 grit. I've been polishing with 120. So what I'm trying to do is eliminate these little bright spots that pop up here. You keep looking, and some of them are quite big, actually. So anyway, I examine this, looking for these little bright spots that kind of pop up on here. Another way I examine is by just kind of putting it up to the light and see even if anything like really pops out, and sometimes they do. Now, the thing is, most of the big pits have disappeared. There's only 2 or 3 left, and that's probably because it's really difficult for these companies to keep larger pieces of something, material contamination out of these bags. So now that I'm down to only 1 or 2 of these pits, I'm going to move up to the 220 and start working on it. And so from now on, I'm going to do about an hour with the 220, an hour with number 320. Then I move to white aluminum oxide from silicon carbide, 25 micron, 15 micron, 9 micron, and then 5 micron. And then the fun part, which is this stuff, this is pine tar. That's the final polishing solution. Pine tar, oh, I'm sorry, I forgot cerium oxide. That's before the pine tar. So there's a lot of hours, as you can see, there's a lot of hours of work left that I have yet to do. Each one of these takes at least an hour. So, God help me. Now, I promised last time I would answer the question, why do it by hand? Why not put it on a machine? And in fact, I have access to a machine at my club, UACNJ, which is United Astronomy Clubs of New Jersey. So why not just use the machine? And that is because of randomness. The fact is that our motion with this thing, back and forth like this, is always random. The amount of pressure I put on with my hands changes constantly. The direction that I move, even though I think I'm moving in the same direction, slight variations every time I move it. And strangely enough, it's the randomness that produces a near perfect spherical surface for my mirror. A machine has not been invented yet that can mimic the randomness of a human hand. So, if I want absolutely, spot on surface to put the silver or aluminum, whatever I'm going to end up putting on top of this thing to make it into a mirror, if I want a really perfect surface, I got to do all the work by hand, and as you can see, it's a lot of work. So next time we're going to hopefully I'm going to be done with all this polishing, and we're going to be moving on to testing the spherical surface, and then you're going to see me cry like a baby, because most likely when we start testing the surface, we're going to see imperfections, serious imperfections in the spherical, quality of the surface, and then we're going to have to fix them, which means even more hours of work. So, before then, I say God bless you all, and take care until we meet again. This is Pastor Bill.